Hi everyone, thanks very much for backing the Digirule. I wanted to make this video to give you a little bit more information about the Excel spreadsheet, how that actually works and how you can start to write some programs. And also we'll run through some examples on the Digirule2 just to get it a little bit more in your head, or what this thing is all about, I guess. So let's first have a look at the spreadsheet. We've got the instructions up here. Now the first thing I'm going to do later on is I'm going to move the halt instruction all the way up here to all zeros, which makes sense to me, and other people have pointed that out, because if you have a look at the Digirule, when we first turn it on, you can see that the address starts at 0, the data within that address is 0. And as I step through all the addresses, it's just filled with zeros. So it makes sense to have halt as all zeros, so it defaults to just the halt instruction. So we've got that, then we've got some variables here. I'll get rid of that for a second. I'll show you that in a moment. So we've got variables in here. You can write your own aliases in here for these different RAM locations, which we'll do in a moment. However, we've got 3 that are pre-configured. LED register is all ones, or 255. Button register is 254. Status register is 253. So we can read and write these locations to, well, if we write to the LED register, it'll show that data on these data LEDs. If we read the button register, well, we're getting the status of these data buttons once the CPU is running. And the status register, well, we can read the status register, or we could write to it really. So status register bit 0 is the 0 flag, and bit 1 is the carry flag. So I'll have a look at that later. All right, let's have a look at just writing some examples. So for example, we have copy LR. That particular instruction, and this will be detailed in the user manual, that instruction requires 3 bytes. So it's got the copy LR in the first byte. The L is a literal value, 0 to 255. And the R is the RAM location that you want to copy it to. So for example, if I wanted to copy the number, let's go 17, into RAM location 128, I'd write it just like that. So let's put that code in, and I'm going to put a halt instruction here, so once we've actually run through that, the CPU will stop. So let's go, what is it, all zeros, yep, save that. 17, save that. Where do we want to copy it to? RAM location 128, save that, and then I want to halt. Save that. Let's go back to the start. Let's run it. When we run it, it'll run very briefly, and then it'll immediately stop because it gets to the halt instruction. Okay, that code is done. If I go to memory location 128, let's go there, we can see that data is now stored in there. If we have a look at the other memory locations above and below that, it's just filled with zeros. However, we've just copied the number 17 to that memory location. If we want to copy a different number, so there's our number that we want to copy. Let's copy all ones. Let's run that code. So we're going to copy all ones, or we have just copied all ones to memory location 128. We can see it's filled with all ones. Now, we don't have to just have a number, 128 for the RAM location. We could have an alias or a nickname. So I had here Brad's variable. So now in Excel, Brad's variable is recognized as that memory location right there, 1111000, or F0 in hexadecimal. So if I put that in here, Brad's variable, it now recognizes that Brad's variable is there. So let's put that code in. So we've got copy LR, yep. What number do you want? Well, let's go to the number 17 again. That's 17. Save. Where do we want to copy it to? I want to copy it here into Brad's variable, and then I'm going to halt. Save. Let's run that. So the code has run. It's got to the halt instruction. It's now stopped. Let's go to that RAM location. And you can see there's our number. 16 plus 1 is 17. All right, easy enough. Let's have a look at reading from a RAM location. So let's go copy RR, which is copy, in fact, let's set the speed first. Let's go speed 129. So this speed allows you to change the, well, it's really the delay between each instruction as the CPU is cycling through once you run it. So the bigger the number here, for example, if we did 255, that would run the slowest because it's waiting like 255 counts really for want of a better way of describing it at the moment. So 255 would be the longest wait between each instruction. So I'm just going to go 129, which is just a habit I've gotten into for the moment, and we'll change that speed a bit later. Now I want to copy RR. So that requires 3 bytes, and that'll be detailed in the instruction manual. I'm going to copy from the button register to the LED register so we can see what button is pressed. So button register to the LED register. Now we don't just want to halt here because it would do it once and then it'd stop. We actually want to keep cycling through here, so we constantly read the button register, send it to the LED register, and don't stop that. So I'm going to have a jump instruction, and I'm going to jump to this particular line, which is line 2. So it keeps cycling through, cycling through, cycling through. So let's run that. Speed 129, copy RR. Now what's the first register you want to copy? I'm going to copy from the button register, or the button RAM location, to the LED register, and then I'm going to jump that. Where am I going to jump to? Line 2. Let's run that code. So it's constantly cycling through. It's not flickering here because it's running so quickly. And every time I press one of these buttons now, you can see that it lights up, and I can do multiple buttons at once and they all light up. Let's stop that. So that's speed. What speed? 129. Let's slow it down. Let's go here. Let's increase that number so that it's a longer delay. Let's now run it, and you can see how slow that CPU is now running in between each cycle, or each instruction I should say. So now when I press a button, it's probably going to have a little bit of a delay between pressing the button and that LED turning on, or releasing the button and turning it off. So that's just setting the speed of the CPU. Okay, cool. Let's now look at like a branch instruction. So let's decrement, and then we'll jump somewhere. Let's get rid of this. So what I'm going to do here is I'm going to go, let's copy literal value. Let's start with 100. Let's copy that to the LED register so we can actually see the number. And then I'm going to decrement RJZ. So this particular instruction requires, well, it requires multiple. We'll have a look at that now. So the dec stands for decrement, which means take one away from. Where do we want to take it away from? Well, we want to take it from a RAM location. What RAM location? Well, that's what we put in here. I'm going to go from LED register. Then it's going to check. Once it's taken one away, it's going to jump if that RAM location contains 0, or if the 0 flag has been set. Alright, so it'll jump these 2 lines. It'll jump over them, because these 2 lines in itself, in fact, I'll put the halt instruction here, because once we've started from 0, counted all the way, started from 100, counted all the way down to 0, I want to then halt the CPU. I'm going to skip these 2 lines because these 2 lines would contain a jump instruction. Where do we want to jump to? We want to jump to 5 there. So let's have a look. We set the speed to 129. We'll change that later. We're going to copy the literal value 100 into the LED register so we can see the number. We're then going to take one away from the LED register, and if that happens to be 0, it'll jump over these 2 lines and land here, which will halt the CPU. If it's not yet 0, it will run this line, which is jump. Where's it going to jump to? It's going to jump to line 5, which is here, which means it'll take one away. It'll check if it's 0. If it's not, it'll jump back up here, take one away. It just keeps going around. So let's run that. Reset it. What have we got here? Speed 129. Copy literal value 100. 110010. Yep, there's our 100. Where do we want to copy that to? LED register. We're going to decrement from the LED register. We're going to decrement the LED register and jump if it's 0. What are we going to jump? We're going to jump this line here, which in itself is a jump instruction, and it wants to jump to 5. But if it is 0, it'll jump to this particular one, which is halt. Okay, there's our program. Once we run it, it'll count down and halt when we get to 0. And there it is there. It's halted once we got to 0. Let's slow the clock speed down a bit. So let's go, say, here. Save that. This might actually be a bit too slow, but let's run it anyway. Let's run. So you can see it's going a lot slower now. And obviously our count stored within the LED register is going really, really slow. Actually, I don't want to wait that long. So let's change the number that we put into the LED register. So speed is that, copy literal value 100. Let's just make it, let's go 16. So let's go here. Okay, let's run. There we go. So it's counting down, counting down. Eventually it'll get to 0 and then it'll halt. All right. Well, that's about all I wanted to show you for the moment. I mean, we could do, I'll do one last thing. Let's do a call and a return instruction. So let's go, so speed 129, let's call what? Call, let's go this particular, let's go call 16. And then when we get to 16, we're going to have a retler statement, which is return with a literal value in the accumulator. What are we going to return with? Let's go 170, which is 10101010. We're going to return with that. And then when it returns, it's going to return to this particular line here. So we've done the call instruction, which requires 2 bytes. It'll call this particular location, 16 down here. And then when it returns, or the number that's in the stack will actually be this. So it'll be the binary representation of 4. So when it returns, it'll be here. And then from there, I'm going to copy the accumulator to a RAM location, LED register. Actually, let's not even do that. We don't even need that. Let's just halt it from there. Let's go halt. No, because we need to be able to see it. Sorry. Let's copy the accumulator to a register, and let's just go, let's go Brad's variable again. That's fine. Then we will halt. Okay, so it sets the speed to 129. It'll call like location 16. So it gets to there, goes, yep, I'm going to go down here. It will return with literal value in the accumulator. The literal value is 170. So it returns to here, which is the program counter location just underneath that call number. It's then going to copy from the accumulator to a RAM location. The RAM location is going to be Brad's variable, and then it will halt. So just to show you how this return thing works when we're returning with a literal value. Okay, speed 129, call 11010. Yep, I'm going to call 16. All right, let's go to 16 now. In fact, so oops. 16, go to, so in 16 we've got 11011, which is our retler instruction, return with literal value in the accumulator. Save that, and the number we want is 170. Save that. Let's go back here. So where were we? So that's speed 129, call 16. Okay, we're up to here. Copy AR. So copy from the accumulator to a RAM location, Brad's variable. Save, and then we're going to have a halt instruction. So it'll halt the CPU. Okay, so this will run very quickly. We'll run that. It's done. Let's go to Brad's variable, which is that location there. And we can see stored in there is that. All right, so this video is getting up to about 15 minutes here, so we'll probably stop there. But hopefully this sheds a bit of light on a few things. But if you've got any other questions, please be sure to let me know. And thank you again, guys.